So I know it says it's a fireside chat. Not going to do it like a fireside chat. I don't want to sit down for a very long time. Such an interesting topic. So let's get started with it. I think AI, especially in the design and construction, is the most disruptive thing that we have seen in the AEC industry so far, and I really do believe it. And so, can you get the audio for this a little bit? I think it will be a very interesting topic today, and especially we are going to talk about AI in design and construction, and let's kind of unlock the mysteries or the fears that we have about AI. So what I think we should do today is, as it's something that it's going to be looking at from all the way history into where we are, I figured it will be a good idea to get somebody from a historic figure to kind of get us, to welcome us here. So I think let's start with Shakespeare and see what he has to say about AI.
Welcome to session on AI in design and construction. Steel Day is the best conference in the modern era.
I agree that Steel Day is the best conference in the modern era, so I agree with Shakespeare. But as you can tell, I mean, this is something that's AI generated. It's kind of there, maybe it's not all that great. So I figured I'll get a friend of mine, Jane, and see what she has to say about it.
Welcome to the session on AI in design and construction. Steel Day is the best place to learn about AI for architects, engineers, contractors, and owners. I am sure everyone will be able to learn something new. I will now hand it over to my friend Abhijit, who believes that AI is the future. So buckle up and enjoy the ride.
As most of you have guessed, this is also an AI-generated image. There is no live person like this. And with the elections coming up, so all the videos that you get on WhatsApp, don't believe all of them, because there's deep fake videos like this that will be going around for sure. So since this is the first time we are doing AI in steel, I figured let's kind of start a little bit from on what AI really is. But we'll be looking at it from three different views or lenses in the AEC industry, from architectural, engineering, and construction, obviously. And to help me here, like we were introduced, I'm Abhijit. Been with Walter P. Moore for over 25 years. And to help me with that, we have a really great panel here, representing the architectural side, Shravan, and Anil from Turner. So I think all these three companies, they're kind of leading the charge on AI in the AEC industry, so we have a good panel. Like I said, let's start with a little bit of what AI is. So as most of you know AI, right? I mean, it's what is it? It's amazing India. Yeah, that's what it is. That's loud. But yeah, of course, we're going to talk about artificial intelligence today. So to help us what that is, let's look at what Stanford University, how it describes AI. So a lot of us think that AI is what is the strong AI, where machines can think and act in a way that matches or surpasses human intelligence, where we're not there yet. And I don't think that's ever going to happen. So what AI currently is basically what we call as weak AI. And weak AI is where the computers can perform actions and activities that humans once performed. They can do it better, faster, but that's what it is. So all we are talking about right now is weak AI. And if you look at it, that's in simpler terms, it's the simulation of human intelligence processes by machines, and especially done by computer systems. Now we can generate tools, other machines which have the backbone of the computer systems, but that's what it is. A quick history, it's all started in the 1950s, believe it or not, and the term AI was coined in 1956. So it's been around for a very long time. 2004 was when NASA actually used it in a significant way in its rover. 2011, IBM Watson, it defeated a human person in Jeopardy. But the first computer to beat the world chess champion was in 1997. And to kind of keep this in perspective, Google was not formed till 1998. So we're talking about a long period of time, but the advancement in a very short period. And today we are talking about OpenAI and ChatGPT that happened in 2022. All right. So, like I said, we are trying to keep it very interactive. So everybody who's heard about ChatGPT, please stand up. Not going to have everybody just sit down. Stand up, no show of hands. Please stand up. Everybody's heard about ChatGPT. All right, so now everybody who's used ChatGPT, keep standing up, everybody else sit down. Whoever's used ChatGPT, keep standing up. Everybody else sit down. Look around the room. These are the people that are going to leave the rest of you behind. Now, the last question. Everybody knows what ChatGPT stands for. Keep standing. Everybody else sit down. What does GPT stand for? All right. I think everybody's sitting down. Okay. So GPT stands for Generative Pre-trained Transformer. That's what it is. So the AI that we are using right now is kind of generative AI. Generative, and as the name suggests, generative means that's something that's created new. Maybe it's text, maybe it's image, audio, a code, a software code, or something like that, audio, video. So that's what generative AI is about. And then obviously it has to be done automatically using a computer program. So that's what generative AI is, and that's what we're talking about. So ChatGPT, I know very few people were standing earlier. Even though you're not using it, your kids are using it. They're using it to do their homeworks. Whether or not it's a good thing or not, that remains to be seen. People in your offices are using it. They're using it to summarize their reports. They're using it to look at PDFs and come up with just a brief summary of what it is. So ChatGPT, or text to text, there's a lot of tools. Gemini is the tool that is developed by Google. But the one thing that most of us will start using very soon is the Copilot, because Microsoft is already kind of introducing it into all their products. So I think next time when we are here, I know Avneet said we are going to be doing AI in steel design every year, which I think, because the progression will be so much, next time I'm sure when I talk about who has used text-to-text GPT, I'm sure everybody is going to be standing up, because all these tools will have AI built into it. So I asked ChatGPT, I told them about what the conference we are going to have today. And then I asked it, what are the questions that I should pose to the audience? I asked ChatGPT that. And then it gave me a list of things. And it depends on the prompt that you're asking. Right? So I said, okay, these people are not very experienced with GPT. And then the questions that came up with, how do you, have you thought about how AI might change your jobs as architects, engineers, and contractors? And what steps are you taking to kind of understand these technologies? Do you understand how AI tools help you manage projects better, and you open exploring these options? Are you aware of the ethical concerns? And this is a very important thing. So these are the type of things that can easily be looked at in ChatGPT. All right, let's not waste too much time here. The next thing is text to image. And so OpenAI has also a product where rather than text to text, you can describe, okay, I want to see something like this, 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 and it will give you, DALL-E will give you that image. There's other tools like Midjourney and Adobe Firefly. So I thought, okay, let me try Adobe Firefly, and gave it a prompt asked it to rendering of a circular cricket stadium with steel and tensile fabric roof, aerial view during sunset. So each of these things after the comma is what I went on adding. So giving the right prompt is a very important thing, and so you might have heard that there's a new term called prompt engineering. How to write the prompt, how to ask the question is becoming more and more critical. As you can see, the result is not all that great actually here, right? I mean, you can see, the surface is not very clear, the steel is all mangled up, but you can keep on adding it. The next thing is I can give it a reference image. So I gave it a Motera Stadium image, and then it kind of changed into something different. But within minutes, all these kind of things can be done. This is a rendering. I asked, okay, I want to see a lobby, in the hotel lobby, looking up. You can give really informative description, it comes up with this. All right. That's plenty of talk about general, and now let's look at it from the AEC standpoint. And this is where our experts are going to help us in here. So we'll start on the architectural side. So Shravan, Gensler, I know, is doing quite a bit. We've started using some of these tools. So do you want to talk about some of that, or do you want me to show your video from Gensler first? Show the video first? All right. So this is a video of one of the tools that Gensler is developing. you want to tell us a little bit about this video and then also talk about your thoughts about what's going to be happening, what you guys are experimenting at Gensler, and what else do you see in the architectural industry?
Sure. Thank you so much. Firstly, thank you so much for having me here. It's a little, I had a vested interest in coming here as well because even though I work in an architectural firm, I'm actually a structural engineer by education. Yeah. So it's kind of I'm really happy to be back here. So within Gensler, there is this platform called the Nform ecosystem, as you saw right at the end. And it's basically a suite of tools that are being developed internally within Gensler to be able to do the various kinds of things that you saw. Now, when we're looking at philosophically, how do we want to look at design technology really coming in to aid us in the process of design, I'm going to use what our design technology expert always uses as an analogy is Iron Man. Right? So he said, look, Iron Man has a suit. Tony Stark has the suit on the outside. Without Tony Stark, the suit is nothing. Right? But the suit really enhances Tony Stark's ability. So when we're kind of developing all of these design technology platforms, the idea is not to automate out the designer. It is to really enhance the abilities of the designer to try to solve problems that traditional processes might not allow them to solve with as many options or with as much innovativeness, right? So for example, if I'm trying to design a large waterfront development, and I would like to be able to see how do I orient all of my buildings to make sure that, say it's a residential development, to allow the maximum number of units, the maximum amount of view to the waterfront, that's something we can do through computation and through AI-based tools right now more effectively, as opposed to me trying to draw it out on a piece of paper or even try to model it in just a SketchUp or a Revit platform on my own, right? So the idea is to try to look at how do we enable designers better, not to automate really, but to enhance. So that's kind of the first philosophical thing that we're looking at. Overall, when we're trying to implement these technologies, as you would know for sure that there is, say, a level of question that comes in, there is a level of doubt that comes in terms of what will this mean for our own jobs, our own skills, etc.
Shravan, if I may, we'll come to that later, the challenges and things like that.
Yes, please.
But other than this, I think the simpler tools, are you seeing in your offices people using this text to image, very simple tools, but something to kind of get the creative juices flowing, if you will?
Yes. So we're being very careful about it, obviously, because, and I think that's another point for a discussion later, is data privacy and all of that, because these are all open source platforms. But we are starting to use, say, a level of ChatGPT in terms of, say, report writing, where there is non-confidential data that's being looked at. There is some amount of Midjourney that we're starting to use to visualize certain types of environments and maybe get a little inspiration right in the beginning when we're conceptualizing projects. So some selective uses of that, but we're being careful about it because veracity of data for AI is still something that's kind of being thought through. So yes, but cautiously.
Yeah. And then the next thing I was going to kind of just show is the text to BIM. So there are a lot of platforms even available to everybody online right now. Oops, what happened? Can you guys see the slide? Yeah. Okay, so text to BIM. So there's online platforms like Hyper, there's TestFit, where basically if as an owner you have a plot of land and then you say, okay, and you can actually geotag it, okay, this is where my land is, right by the airport in Mumbai or whatever. And then you can say, okay, I want to look at building a hotel here. So you just do inputs. Okay, I want the hotel to be 10 stories tall. Then you change it. No, I want it in U shape. Then it automatically changes it. I want the first 3 floors to be parking, plaza, this, that. It automatically does that. Not only that, it will take, and we'll get into the engineering side a little bit later, but it will take very conceptual designs of, okay, the column sizes, the beam sizes, and typically most of this is being done in steel right now, but it will show that. So there is some amount of design that's going on. Obviously, it's just conceptual and schematic level right now. But what are your thoughts on that, this text to BIM kind of
See, ultimately, all of these platforms are going to give inputs based on what is the problem that we're trying to solve.
Right.
identifying that problem statement is starting to become a skill in itself, right? So earlier what we do is we just try to, intuitively we kind of do this in our heads, but we wouldn't explicitly kind of put out there. To be honest, before AI came in, that stating the problem correctly started to come in with a level of computational.
Correct.
Right? So when we started to get into computational design, we really had to see what was the parameter that we wanted to optimize, what was the parameter that we wanted to maximize or minimize. And so with that, things started coming in, and that's now stepped into overdrive when we're looking at text to BIM.
Yeah, you're absolutely right. So parametric modeling, I mean, that's all based on data. And as we'll see a little later on, I mean, all this we're talking about AI and machine learning, it's all based and grounded on data. So the level of data that you have, and some of these tools, maybe they don't qualify as true AIs right now yet, but we are collecting the data, we're using the data, and so that's where the future is, using this data to build better tools. I guess let's move to the engineering side. I think I'm gonna get up a little bit. The new paradigm, I think, on the engineering side is to how do we leverage precedents? How do we use machine learning to guide us through the process that ensures high quality but also transparent decision making? And so, I'm not going to go through all of these, but I'll let you guys read this. But we can generate multiple matrices. With this, we can make sure that no effort is wasted. So all these tools are just to quickly generate something that can be used as a conceptual or schematic design. And we'll get into the ethics part of it later on, but none of the AI tools, I think what we are developing right now, can be used in actual or CD documentation or good for construction documents yet. And there's good reasons for that. I want to just show you what we are doing at Walter P. Moore, and all the development that's happening in emerging tech can be categorized into 4 groups. Basically, it's streamlined and curated process for design exploration, the conceptual design. Then there's a whole new set of comprehensive trusted solutions for complete detailed design. Now that's not AI, that's actually solvers and parametric modeling. So this is not AI, this is actual design. But then the fast ML-informed design functions accessible from anywhere. And I'll talk a little bit about this. And all of this is kind of built on a common data platform because that's very critical. The ML part of it is, we call it emulation lab, and we take small problems and solve it. Project Lightning is the fast way of using some ML tools and look at conceptual stuff. Then we have in-house design tools which are for final production design. But all of this is based on something that we call SID. And I just want to take a minute to just say what SID is, because data, all the different models, I have a lot of architects, engineers sitting here. If we just even look at the engineering and documentation model, we have SAP, ETABS, Revit, Tekla. So if we want the data to kind of flow from one to the other, there's already so many connectors that you would have to build. And then if you add the Rhino and the Navisworks and the Grasshoppers and the GSA, there's a lot of data and connections. So we don't want to develop different models for different things. So we've in-house built something called the SID, which kind of takes information from Revit, Tekla, your Rhino, Grasshopper, parametric models, and it connects everything together. So this is the center interportability database. And this is not something special to Walter P. Moore, if I may say. I mean, there's other companies who are doing their own things which is similar. But what I want to encourage all of you guys to do is start thinking about digitization of your work, because the data is going to be very critical. So all these connections can be built and then data can be harvested. So emulation lab. So I said, if you think about machine learning on AI, we can solve any problem that's repetitive. That could be design of a steel beam, checking buckling of a column. So very small tools which are done over and over and over again. So in an engineering firm, I know we've designed hundreds of thousands of beams. So if you capture all that data, and the next time you're going to say, okay, there's a 30-foot span beam with this kind of load, it automatically knows what the answer is. And this is what these small tools are. And that's when you combine it into the Project Lightning. So these are our tools that are developed by in-house engineers and used by in-house engineers. And here we can actually see what is the data that your machine learning is giving you the answer versus what is the calculated answer. And you can actually compare those two. So this is something that younger engineers use quite a bit. And this is Project Lightning, which says, it's kind of beta version right now. So you can just basically take in just a outline plan from architectural drawing, and it creates the column locations. Then you can go in and start doing, you can say, okay, it wants to be these number of floors, this is the area, then it starts building the model automatically. And then the model is generated, and then you can look at the different levels of the model. You can go back and say, okay, not 15 stories, I want the building to only be 5 stories tall. So you can change it. And so it keeps on and kind of updating those changes. And then you can change the deck type, the concrete weight, whether it's lightweight concrete, normal weight concrete. You can do all those things. And then in the background, once you're done with all that, it'll start using the machine learning tools to come up with different options. So what it'll do is it'll come up, in this case, we've set it up to do 5 options. So 5 different designs it'll show, and for each design, what is the number of, what is the total steel count, I mean number of pieces, what is the total weight. We can look at what is the embodied carbon from a sustainability standpoint. So what option do you want to choose? It's up to you. But again, these are not final designs. So these are the different options that you'll see at the bottom. It came up with 5 different options. And then the kind of the material that was used. So this is kind of one example of where it's headed. So we are experimenting with things like that right now. And this is another tool which we call Wally Tally. This is kind of based on the SID platform, and it's kind of an online thing now for cloud computing. And we kind of look at the embodied carbon in each of these different solutions. So we can look at, okay, what was the embodied carbon from the selection of the members that was done. And then we can compare it with different projects that we have in our database. So depending on the type of project, you can choose and see, okay, how does this particular project fit into the whole thing? So that's kind of where we're headed. So it kind of gives you an idea that, okay, if it's 2 similar buildings, similar type of structures, then you can know, okay, on the rest of the buildings, where does your building fall? Again, data. Data is what all this is kind of built on. And then you can create reports on that and all those things. Not going to waste a lot of time here. Important thing here is all these tools that you'll see, that you saw, these are solving specific problems. These are in-house tools. And by the time we talk again next year or even before that, these tools will be done. They'll be disrupted. There'll be new things coming because the new data is being created. So we need to, if we don't disrupt ourselves, there's somebody else who's going to be disrupting us. Maybe it's another human, or maybe it's some other machine or AI or ML related tool. So this is what we need to be thinking about. It's a constant progression. All right, so with that, we're going to head into construction now. So Anil, do you want me to kind of play the first video, or do you want to make some opening comments before we do that?
No, I think you can start the video and probably we can take it up after that.
All right. So the first video is about crane view, which is something that can be installed on the crane, and let's look at it.
Our construction company is targeting innovations that unlock the potential of that data to provide insights that drive action and generate positive outcomes. At the heart of the modern construction site is the crane. It sets the pace of the project and provides unique opportunities for data capture and analytics. This is what versatile crane view technology delivers.
Crane view
It helps us learn from day to day and apply improvements in real time during the project. It's a large project with many trades vying for the use of the tower crane, so gaining efficiency is vitally important. With Crane View, we measure our performance and constantly look for opportunities to improve. We have been able to quickly establish typical cycle times for a variety of activities that repeat from floor to floor. This gives us opportunities to look for areas of improvement and makes it easy to identify outliers when they occur, and then apply what we've learned to make any needed adjustments.
We also leveraged Crane View data to find the most efficient scheme for rebar installation. Using Crane View to experiment with different schemes, our team was able to reduce the critical path duration of our cycle by 30%. And we were able to identify this early and reap the benefits over the next 600 vertical feet. The efficiencies we were able to gain allowed the trades to cut the time they anticipated the install taking in half.
Yeah. Good morning to all. Thank you for inviting on this panel discussion. It's wonderful to be among these esteemed people who are all gathered here. Being Turner, of course, I'm part of a department called Innovation, and what we were showing is the pilot projects that we have started utilizing. And there are a couple of examples which we are trying to bring in here. And Innovation Department's last November when the event was held in New York, and it talked about, incidentally, AI to IA, which mentions intelligence augmented. AI, you know, and IA is intelligence augmented. We are in an industry where there is so many support people are required to do construction. How human intelligence and artificial intelligence can bind together and bring that efficiency, productivity, speed is important. What we showed down here is a product where most of the construction is now based on hoisting as well as on the crane. And crane is augmented with AI, which actually been able to not only do shift to the place where it is supposed to go, but also does the productivity analysis of how it is getting utilized. And the productivity keeps increasing because of that. I think that's one of the aspects that we have tested as a pilot. In fact, we are talks for one of the projects in India too, not yet materialized. So it will be interesting to see how India also receives this.
Thanks. One of the things, I mean, from a construction standpoint, obviously is safety. And I think it was mentioned earlier on how labor and, I mean, operator safety. So in the crane operator is kind of one of the most, I don't know what we call it, the guy who has a lot of fatigue because you go up the crane, a lot of them spend the entire day up there. So you've seen these kind of technology coming into your cars as well, where the cameras detect if you're falling asleep or something like that, and it will alert you. So same thing is being used in the cranes as well, right?
Yes, those are the sensors that are available. And I would like to touch upon one more thing. It's not only about the crane safety, it is also about humans who are actually physically working there.
Yeah.
And one of the important aspects which again we are trying to utilize and find out is number of people. It's kind of a wearable device. It's the dehydration that causes this fatigue. So there is already a pilot which we are again doing in US because we do SPD, which is basically self-performing department, where we hire laborers and we actually engage. So where wearable devices are used to see the hydration levels, and before he gets dehydrated and does mistake and not able to concentrate, it gives an alarm to see that you get hydrated. So that's also being used currently.
Okay. So this next video, the next example is about combining BIM and how actually it can be used on site. This is one of the examples. There's a lot of wearable devices and things like that, but let's look at this one.
OpenSpace offers an automated 360 photo documentation solution. We do that by taking an off-the-shelf 360 camera, mounting it to your hard hat using one of these magnetic mounts, and pairing it with our mobile phone app for iOS and Android. Think of that like a remote control, ultimately a start and stop button in your hand rather than top of your head. OpenSpace as a software then takes all of the photos that these cameras are capturing and automatically pin it to your floor plan using our vision engine. So that process looks something like this. Strap your camera on, hit record, and walk. It's very much that simple. The output is then something like this. This green squiggly line on the right is the path you've taken as you've walked around site. Think of it as OpenSpace dropping digital breadcrumbs as you're walking around. And then on the left, you've got this beautiful 360-degree view, just like Google Street View, of what you've captured on site. So if we jump into a project, you'll see here if I click my mouse and drag, we'll have that full 360-degree view, just like we would with Google Street View. If we look up, we've got ceilings, down we've got floors, we see it mounted to our friend's hard hat here. Next we've got our data picker tool, And this allows us to go back in time. So if we want to see the status of a room maybe 2, 3, 4 months ago, this allows us to go back and have a look at a snapshot of what the status was like back then. Things I like to show in our core product is our BIM model viewer. And so if you have a BIM model on your project, using the Autodesk Forge integration, what we're able to do is upload your model very easily into OpenSpace and be able to align that with your captures. The Vision Engine does this automatically for you, so there's no heavy lifting on your side. You would simply come in, upload your model, and then once it's aligned, when you log in, this is the view you will be met with. One of the things I love about this is that it enables people who aren't used to using a BIM model the ability to be able to walk through it easily.
Yeah, just touching upon this, this is not the only product that we use. We are 100% compliant on using a 360-degree camera, which is integratable to 3D BIM on all the projects across India now. And what it is giving an advantage is basically able to understand it. Now I talked about 3D, but we are able to do actually 4D simulation onto it and get the render out saying that this is what it is today. And it tells us how the works are progressing month by month, because this is captured on a weekly basis. And it tells where are you headed, say next 4 months, next 6 months. And that gives a great insight to the end user saying whether we are, how are we performing. Another important aspect that we touched upon, and we have already utilized this as a pilot in one of the projects, is actually getting the reverse utilization of not only the capture, but transferring it back into BIM, which is basically as-built documentation. And one of the sponsors here, Phoenix, who are the developers, we experimented on one of their projects, and handover was very much smooth to the facility managers, because the biggest thing that happens is as-built documentation. Various vendors and people are not able to put digitized thing back into the drawings, and it takes months together to reach there. So what this has done to us is basically it's got a measuring tool. We have cut that video for the paucity of time. You can measure it. You can find what was in design and what is the actual executed at site. Before the ceiling closure, it gets documented, because it's on a weekly basis, that this is where it lies, and you can measure and find the actual place where the walls are and where the fire dampers are and where it can be located. And how the facility manager gets, it is 100% as-built. There are no errors. There are no, because when you get as-built documentation, you know, we get thousands of drawings back, and humanly not possible to check.
Right.
This became a good tool to give it to the facility manager, that whenever there are changes, he is able to adapt. New clients coming into the building and say, I want a tap-off from here, he can actually visualize that and see that he can put it together. That's where it is. Of course, there are various other parameters which we have utilized. Again, paucity of time we have cut. We have used the same tool to do the markups on all the snag lists. So it is very easy, because it is worn on a helmet or a handheld device, and it's on your phone. And when he walks with the engineer and is pointing it out, he marks it out on the mobile and comes back and assigns it to the vendors or whoever is supposed to correct it as a snags. And it gets tabulated in an Excel with a GIS link, so that I don't need to tell left side or north wall, this height you need to look at. And it actually gets documented, and even the snag closure happened through this. So that became the document for handover to a facility management. And they were really happy that the data was correctly transferred, and they actually knew week over week how we were progressing, because all was on one tool.
Yeah. Thank you. The other kind of aspect in construction is we've seen robotics being used in automobile industry and so forth, so on and so forth. And it's kind of eventually started coming in our AEC industry as well. But in the past few years, where I think it's becoming more exciting is with the use of AI kind of algorithms and at the back end. Because what it's doing is now you can actually read, and the same similar kind of algorithms that we looked at, when you look at something, it kind of understand what it is. So I'm going to show a quick video of something that is used for painting, and I'll tell you why I'm showing this. So here I think, you'd see, okay, it's just a simple painting job. Why do you need a robot to do this? And some of these things are not widely used yet, but I think, yeah, the robots can go and paint your structures and things like that. But what's more exciting is when you are actually doing that, and when the operator kind of leaves the robot, it's actually looking at the room. The video is being captured, and it understands, it's creating an existing kind of a 3D model of the space. So it knows where to stop. There's an opening. Then it continues up ahead, and so on and so forth. So it actually creates an entire 3D model itself of existing, and then it kind of uses that. So similar kind of things in data collection, the previous thing that we saw, cloud computing. So these kind of things are coming. And from a steel industry standpoint, I think automatic welding things and things, they are also, eventually they are going to be coming there. There's all in experimentation mode right now, but it's just kind of the beginning. And the other thing, Anil, I wanted to show, one of the devices that he showed, the camera on top. Another thing that Turner is doing is using this, one of the companies that leading in robotics is Boston Robotics, and they have this, you must have seen the robotic dog. And now it's kind of going to the next level, and there's a quick video on what it does in, it's called Spot. So Boston Dynamics is really changing the game in robotics, and as new and new tools are being developed, I think they are just doing a phenomenal job, and I have no doubt that this will become mainstream in the next few years, because the data this is collecting is going to be widely used. We can create point clouds from there. I'm going to talk about a couple of applications here, but Anil, there's a couple other things that we quickly need to touch on, and this supply chain optimization using AI is another thing from a construction standpoint, if you want to say something about that. Yeah.
This is another place where, because we do billions of dollars of work that happens, and there are various vendors and inventories and managing so many things regarding logistics. Supply chain optimization, AI algorithm has been helping a lot. And because of these algorithms that are written specific to what Turner does within our system and how we want to utilize, I think it has ensured a couple of things to turn around quite fast. One is the purchase, inventory management and logistics, and second component is actually creating the contracts. Basically, so many contracts you end up executing because you're self-performing. It was difficult to actually somebody types in and puts in all the required things. So it actually learns from our old contracts and is able to form multiple contracts quite fast. And that is in experimentation, and almost we have been using it.
Yeah. And the next thing I wanted to quickly talk about is predictive maintenance. Especially, with from a steel structure standpoint, I think with the use of IoT and other sensors, it can detect the deterioration, and I'm going to show some examples here in a little bit, but the potential failure. So you can actually predict what parts are going to be failing first, and so the expensive repairs costly repairs can be done pretty quickly. And The other part is from the BIM to FIM. What Anil talked about earlier was we looked at creating the existing model, but then that same thing can be used with tools. It can predict the people movement, like time of the day and things like that, and how it can be done. And it can be your systems, both lighting, HVAC systems can be optimized significantly. There's a company in Singapore who's already started doing that on a pretty extensive scale, and the results are pretty amazing. And we are talking about companies who already have the automated where lighting shuts off and things like that. This is taking it to the next level, looking at human behavior, taking it, and there's, in addition to what they were doing earlier, it's kind of reducing 9 to 10% of their energy efficiency. I will quickly move on to post-construction things. So now this is something that I'm really excited about, the building envelope inspection. Because I told you earlier what we are doing at Walter P. Moore, that's something that we're not using in the final product yet. But this we are actually using in the final product. So what building envelope inspection is, so videography is done through drones or robots. It detects the defects based on imagery, and then it's mapped in the 3D model, and then a 3D model is created using photogrammetry. So data capture, oops, I'm going in the wrong direction here, sorry. Is done, then the AI processing, 3D model is built, defect mapping is done, and then we give a customer portal to that. So we've actually, what we've done is we've looked at our diagnostic group, we've looked at all the photographs that we had over like 20, 25 years, and we trained the model, okay, this green thing, this is a crack, this is a rebar, this is what spalling looks like. And now the model is so well done because we had so many photographs and so many things that we could learn from. And so it can easily detect defects. Okay, if you see something like this, that's when it's spalling. This is kind of the depth of the spall and things like that. And so we have this asset management program which we are using on live projects now. In this one, we are looking at spalling and cracking. And we can actually look at the pictures. It comes back, and we are using these high-powered drones. And we comes up with pictures and shows us exactly, okay, this is a very small crack here and things like that. This is the drone captured 3D model, and hopefully this works. Yeah, so you don't even, so the thing that engineers would take almost like 2-3 weeks to actually go in this hazardous environment, look at things, look at all the things, it can be done in a couple of hours. You don't even have to fly the robot yourself, the drone yourself. It automatically knows where to fly, and it kind of comes up and looks at all the cracks, whether there's spalling, all that is captured by itself. So this is, I think, is a pretty good tool that actual machine learning and AI is being used currently. So the red lines that you see on top where the sealant joint has failed, and we also look at the pavement where there's cracking in pavement. So from an asset management standpoint, this can be a really useful tool. Similarly, for hyperbolic cooling towers, we were able to use that, fly the drone and come up with exactly where the cracking is. And all these different kinds of robots, we talked about it, whether it's drones or robot, we can kind of come up with this information. But especially when there's a collapse, the drone or the robot can go in and kind of look at this thing. There's a fire hazard or there's a fire building. So rather than putting your employees at harm's way, I think you can go in and collect this information and create 3D models with that. All right, that's a lot of stuff we talked about. Now I want to talk about current challenges and ethical concerns. I know, Shravan, we've been talking about construction for quite some time. Why don't we start with you? What do you think the current challenges are in using AI/ML tools, and if you can think about any ethical concerns?
Sure. So we're relatively in early stages as far as AI is concerned. I think there's, there is, its ability to curate the correct information is still a little bit in question. So, for example, you give certain prompts, ChatGPT will give you answers with great confidence that may be wrong, right? So there is a certain amount of veracity of data that is still being kind of verified with this. So it's not kind of, going to just be this Ramban Aushadhi that's just going to cure everything. Yeah. There is that level of challenge that is being looked at. Second challenge that is is of concern, especially within the, within a lot of the corporate industry that we're talking about, is data privacy, right? And data privacy laws as they pertain not only to globe, but also to respective countries. Everyone has their data privacy laws. The companies have their own laws. So what can we really put out there in the domains where you have these publicly available AI engines that are there is something that's being worked around. And so that is a little bit of a challenge as well. So because of this currently, what's happening with a lot of different companies is they're trying to develop their own internal AI technology using any of these as engines because they need to have that level of proprietorship in terms of whatever data they're generating as well, right? So those are probably two big challenges. And ethical concerns, to be honest, is mainly, look, it's a tool at the end of the day. It can be used for good, it can be used for bad, right? It can cut both ways. I think the big thing that we're trying to when we're saying that we're looking at AI to enhance human ability as opposed to replace it, is that then there is a human still there that's kind of making the decision at the end of the day, and making sure that things are ethically aligned in that sense, as opposed to, because AI will be ethically neutral unless it starts to get trained on what is good and bad, and morality engines are a step away right now. We're right now just trying to get to a level of predictive data. Not predictive morality is a whole other ball of wax.
And the other thing I'm a little scared of is somebody who's not very proficient in understanding the tools. Maybe I've been saying that these kind of designs should not be used for construction yet. What if somebody does use it and it's not being checked? So all those kind of concerns are real. And I think I do want to save some time for a question answer session here. So we'll kind of move on here a little bit. I just wanted to also start, how do companies start with their AI journey, right? I think, I don't really want to read the whole thing, but identify power users, a few employees in your company, and then define a benefit, something that a good use case, evaluate the risk and consideration, and then develop an internal product. I'm going to go back to the Stanford model that the AI factory feeds data and insights into the software-enabled operating core. So if you see here, so there has to be a data pipeline, and this again goes to the ethical part as well. So you gather the data, but you need to clean it. You need to make sure that it applies, that you have to normalize it, and then you can use it. Then you do the algorithm development, and then the infrastructure development. But before you go any further, it has to be in the experimentation phase. And then you kind of prioritize and then deliver. So this thing about predictions, pattern recognition, and then process automation is kind of the three-step tool that we need to look at. So as we start thinking about what can AI do and what it can't do, so if we ask, hey AI, what can you do? And so this is one of the answers.
I can detect anomalous data. I can perform surgeries. I can speak hundreds of languages. I can make millions of trades and billions of dollars. I can build automobiles. I can build machines that build automobiles. I can build machines that build automobiles that drive themselves. I can instantaneously answer your questions about sports, politics, celebrities who are famous for being famous, the weird smell coming from your kitchen sink, the meaning of life, and honey badgers. I can do the work of lawyers, doctors, drivers, investors, engineers, accountants, pilots, and IT professionals. I can do thousands of jobs held by millions of people.
People, like you. But she has limits, because technology has limits. Technology can gobble up data and spit it out again, but it lacks the context to tell you what's most important. Artificial intelligence can answer complex questions, but it doesn't possess the creativity to pose them. Machine learning can make businesses more efficient, but it can't dream up new ways to accomplish your mission. Creativity, inspiration, ideas, the big tomorrow, these are human concepts. And in these areas, technology can't compete with you, or the person next to you.
So I want to end with this one last quote. Karim Lakhani is an expert in AI and ML from Stanford University again. And it says AI won't replace humans. And I truly do believe that. But Humans with AI will replace humans without AI. And that's something that we need to remember, that humans with AI, I'm going to say it again, will replace humans without AI. And the way to think about it, in the steel design conference, we talk about concrete or steel, but instead, no, hybrid is what is important. So I would say it's hybrid intelligence is what we should be thinking about. It's human intelligence combined with artificial intelligence, and human intelligence is where we are, our hybrid intelligence is where we are headed. So with that, I think I'm gonna close our discussion and open it up to any questions anybody might have. Hopefully this was a little informative.
Hi, I'm Ruchir Panwar. I'm an architect, and I've always been focusing on new technologies. So my question to you, Pranav, Shravan, is that, if you have your own in-house data, which is what's powering your tool, how is it going to be possible? Because at the preliminary level, irrespective of who is trying to generate a preliminary design analysis, how is it going to be different? I mean, everybody is just going to keep generating the same thing, depending on the fact that your prioritization of your parameters is going to be the same. Because that's obviously the team leader's job. So he gives it to somebody else. So it's architect A, architect B, C, D. In the whole team, they're all going to land up with the same end result because it's driven by the same data.
That's a great question, and this is where that human and hybrid intelligence that Abhijit was talking about comes in great. See, the role of the designer or in this process ends up becoming more from creator to curator. In the sense that we talked initially about how you're setting up your problem. Different people will set up their problems differently to be able to. So if I'm hearing a client, a human, I'm interacting with another human, I'm kind of taking down what is the brief for the project or what are their aspirations around it in a certain way. I have then identified, okay, here are the top 5 priorities that we'll have. Me as a person will do it differently from the person who sits next to me. Yep. Then we will look at all of the options that AI generates for the set of problems that we're looking at. And again, using our sensibilities, curate which are the right options to then take to a client. So what the AI tool is really helping you do is, it's helping you generate larger number of options and checking feasibility of those options at the back. But as that last video showed, the context piece, it will not be able to tell you here's the best solution for the problem. That's where humans will again come in, and different people will have. So each firm, even using the same AI engine, will come to you with different solutions. It's been a surprising process for us as well to find that out.
If I have to add to that, we are working with Gensler on one of the projects, and I was suspicious of the same thing, that it will be a breakaway and same models will keep coming. And hats off to that, it actually came out with, we were saying you should at least bring 6 options, and they brought 15 options, and they were varied. And that's where human intelligence and artificial intelligence combine. Otherwise, I was thinking it's going to come the same thing. I know you have done 100 projects, it will replicate one of them, and it will be similar to one of the things. That was not the case, just to augment his argument.
Absolutely.
Yeah. I'm Sridhar Reddy, structural engineer. I know there is a leap in the technology.
No, we can't really hear you.
Yeah, a little louder, please.
Yeah. Sridhar Reddy, structural engineer. I know there is a leap in the technology, what you people are telling us. So how to judge each of the things, like, let's say engineering only. So when we are designing the structures, so there are different tools available now, STAD and ETABS, all those things. I mean, each STAD gives us certain kind of results, and the ETAB also gives certain kind of results. So even in such case also, we are still not able to judge everything as such. But when it comes to the AI, that next leap into the technology, so it becomes too much of a confusion. What do you say in that aspect? Can you please tell us?
So if I understand the question correctly, you're saying even with the tools that we have right now, like SAP would give you one answer, ETABS would give you another, and then now we're adding this layer of AI on top of that, and how, is that, do I understand the question correctly? Yeah. So you're absolutely right. I mean, I think SAP and ETABS would give you different answers because again, it comes down to the person who's doing it. Even because at the end of the day, there's solvers behind it. There's different methods that they are using. You know better than anybody else. I mean, it depends on how you model it, the boundary conditions and all that. But bringing AI into it, I would say it's not or never going to give you the perfect answer. It would be 90–95% correct right now. And that's why using it for what it is, using it for concept schematic designs is where we are right now. We are not in the strong AI yet. We are in the weak AI level. But still, it's pretty useful. When I say that, let's say a modeler is, in our office is modeling something in Revit. And when he or she, they are kind of modeling a beam which is, let's say, 30-foot span, then automatically, rather than just drawing a line, it knows from the type of building that, okay, this should be a W14 or a W24. So it kind of models that correctly. That's where we are. That's some of the things that can be done. And at the end of the day, I think, like I said, unless it's verified rigorously, I think it's dangerous to use it. So I think that's where I think we are as an industry. But it's kind of changing rapidly. That's why if there's one message that I can bring today, it's like the last sentence that I said. Humans with AI will kind of replace humans without AI, because that's where it's headed. And just one last thing. Some of the softwares that you are talking about, they've started looking at, and we are kind of beta testing some of that, ETABS and SAP, they've started using AI ML tools within their algorithms as well to kind of do these simple things. So that's coming because they don't want to be left behind. They are kind of looking at these things as well while all of the rest of the world is doing it. And there's companies like the Googles of the world, they are looking at AEC industry as well. So it's not just our fraternity. The people outside of the AEC industry are looking into that, and the software developers themselves, the software that we use, they are looking into it and kind of trying to see how, because they have the massive amount of data. Now that we are using BIM and everything that's on the cloud, all the software, they have all the data. And so the data privacy that Shravan brought about, that's another thing. All these ChatGPT tools that were used, they pretty much read everything, all the parameters, all the language, everything there was to read, they have already read that. So what they did is, for example, YouTube, they kind of bent the rules a little bit, and you guys can read about it, but they converted that YouTube videos into text and then read all that, and used that in their machines as well. So there's nothing else left to be read almost. So the tools are getting developed, incorporating these things as well.
And I'll say, look, the thing that I'll add overall is you won't use AI for the sake of using AI. There's got to be a purpose for it. You have to identify what is the use case. So it always starts with what is the question that we're trying to solve. And then AI can help you solve it. I think we don't want to look at it as saying, we need to use AI, how do we use AI? It's what the problems that we're needing to solve and how can AI help us do that. So identification of problem is step one, right? So if we have, for example, okay, for example, when you talked about STAD, ETABS, all of these models, and you know, there are people currently doing a lot of that. There is whenever we look at structural design overall, there is structural analysis and structural design, right? So which is where you're first breaking down the structure into its various components versus where you say, okay, this column has so much moment, so much force, and so therefore this should be the sizing of it, this should be the rebar on it. The second part of it is relatively automated, or is relatively automatic and repeatable. The first part is where human ingenuity really comes in, which is understanding and disseminating the structure into its various components. So then you will say, okay, I'm having trouble finding, say, people out in the market. I'm not being able to scale my firm. Can I look at using AI for the second part, right, to be able to automate that part, or to be able to kind of do that part, because that's a repeatable function, and really focus on finding innovative people who are focused on structural analysis as opposed to structural design. right? So the problem statement has to come first. Then AI can help you. Yeah. Please don't look at AI as something that you have to use for the sake of using it, right?
I think with that, we can, it says time's up, but let's take one last question and then we'll call it quit. I thought I left 10 minutes for question answer session. Maybe that wasn't enough.
Hi, good morning. My name is Manoj Thakur. With regard to this AI, can you elaborate on how this AI can be, or whether it is being utilized to optimize the steel fabrication process or any manufacturing process, or improve the this material utilization and reduce the waste in this construction industry?
Yeah, so I think everybody's telling me to shut it down, but we didn't even scratch the surface on fabrication and erection today. So there's a whole lot of other things. Anil talked a little bit about kind of optimization and the data. So for fabricators, there's so many tools that can be developed, and I think it's like Shravan said, I think look at the problem and then try to solve it. But to answer your question in a small answer, fabricators are starting to do it, have already started doing that. I think with that, I know there's a question, but time is up. I think we can take it offline.
We can take it one question. I think he really was very enthusiastic about it. Let's do it.
Okay, go ahead.
Yeah, just wanted to understand that, here we are talking about simpler algorithms. But then going forward, when there is very complex algorithm which is not understandable by humans, who's going to curate that one has to use that?
Yeah.
Because right now we are talking about very simple algorithms that, optimization of steel, waste, all those things. But then I'm talking about higher level, complex algorithms which are not very understandable by humans.
Yeah.
So here you're talking about, that AI is a aid to humans. But then there's a different perspective where it's humanly impossible for a human to understand that algorithm because of the complexity of,
right.
So who's going to curate that?
You're absolutely right. This is it. I mean, like all the software that we use, it's a lot of times we call it the black box. So garbage in, garbage out. So you need to understand what happens in that box, and that's the reason exactly why you talked about the current tools that we're looking at very simple things. Just looking at simple beam design, something that's very repetitive and that can be easily done. Even the tool that I showed you, okay, this is a crack, that's it. There's nothing more complicated than that. And that's where, because as engineers and architects, we are dealing with a lot of safety and risk, and we're dealing with human life. So we don't want to do complex algorithms that kind of do something that we don't understand what happens.
No, but then currently also you're using predictive solutions, you're giving predictive solutions, no? AI is giving predictive solutions. So it's like simulation and throwing out maybe 50 solutions.
See,
who's going to curate that?
There's a very simple way to think about it, okay? So when computers started, you needed to know hexadecimal coding. Then we developed programming languages, operating systems, applications. Today, I use a Microsoft Excel without understanding the code of Microsoft Excel. What did the Microsoft engineers put into that code, right? That's how AI is also going to be developed. We're at the building blocks level today. Once the veracity of building blocks is done, then using those building blocks, the next level will get built. Once that is tested. So slowly, we will start using these in an integrated way. You will always have professionals who need to understand what's going on below. But the common person, you and me, don't have to. We will be looking at, and that's why I said that the data veracity component is so critical. Before you start relying on it, see, Excel before, now the entire world financial system rests on Excel only because its veracity is, there is a certain amount of rigor it has gone through, right? So that rigor testing has to happen. That hasn't happened yet. Until that happens, you're right. We will not be able to just say that, okay, whatever's coming out, we trust it implicitly, right? So we will have to build that trust with AI over time. We're not there yet. Once we get there, then we can start getting to more complex. Till then, we're not going to get to more complex.
All right,
Part of the ethics, I think, that's what you were talking about, and that's going to be algorithm has bias, has got wrong data and all the other verification. I think codes are being developed. I think Europe has started doing the AI code, what it should have, freedom, privacy, data protection, and various other parameters that have been taken into consideration. So all that it has to go through. Right now it is unverified. That's the reason we have to be careful.
Yeah, I think let's, I know you have something else to say, but we can take it offline. One last comment is to people who are building these tools, at least in our firm, they're not only software engineers, but they're civil engineers who are passionate about software, or software engineers who understand civil engineering. So it's not a totally black box, because it has to have that reference. All right, I think with that, we are going to close it. Thank you very much. You've been a patient audience for about an hour.